Hello and welcome to the Chandra Academy. In today's video, we are going to find out about the tangent function, which is written tan. The tangent function is a very important function within the trigonometric functions. This is defined on an interval that I called, on a set that I called d tan, which is a part of R, and that gives values to R. And that given x will give tan of x, which is equal to the sinus of x over the cosinus of x. In the first question of the exercise, we are going to try to find tan, the domain of definition of the tangent, and then we are going to prove some inequality. So what does it mean when we want to find the domain of definition of a function? Basically, we want to find a set that gives no problem or just makes sense. Give no problem or just make sense. So here, what we want to do is to find, so where does the problem can come from? It can come from a division by 0, because sinus of x is defined for all x, cosinus of x is defined for all x, but we don't want to have a division by 0, okay? So we want this is defined for all x with cosinus of x different from 0. And we are going to find a set of x, the largest set of x, that allows us to have this equality. So let's think a little bit. Here is a trigonometric circle with the cosinus here and the sinus here. My cosinus will be equal to 0 in this point and this point. So it can be equal to 0 in pi over 2 and 3 pi over 2, but also every one of these angles if we add 2k pi, okay, with k a relative number, because let's remember that an angle alpha is the same angle if I add 2k pi with k a relative number. So just if I get an angle and I do one turnaround plus 2 pi, this is the same angle. If I do minus 1 turnaround, this is the same angle. So here we have plus 2k pi with k in z. But this is also the same thing as just saying pi over 2 plus 2 pi plus k pi, okay? Because plus k pi means that I've got pi over 2 plus 1/2 of a turn plus 1/2 of a turn plus 1/2 of a turn. So the solution is x is equal to pi over 2 plus k times pi, with k a relative number. That means that I've got pi over 2 and plus sometimes either positive or negative half a circle. So if I got pi over 2, for instance, here, I can add pi over 2, and here k will be equal to 1, but I can also subtract pi over 2, so k is equal to minus 1. I will be here and come to minus pi over 2. I can repeat this process as much time as I want, but I have to have this equality, okay? And if I want to write this down as a set, I can say that our domain of definition d of t, of course at your level you don't have to write everything like that, but this is important for you to start to see it, because in university you will see it, is equal to all the real numbers, but I get rid, so the backslash is getting rid of the set that allows, so the set of x's in R, such as x is equal to pi over 2 plus k pi with k in z, okay? So my domain of definition is all R's, but those points basically. Okay, so this thing is the expression of the points we do not want. And so what are the points we want? All the points possible, backslash, so without the points we don't want. And this is our solution. Of course, you don't have to write it down like that. Maybe we can ask you what is the domain of definition inside 0 to pi, and inside 0 to pi this is 0 to pi without pi over 2 and 3 pi over 3, but at your level we don't want you to know this kind of expressions. Okay, then we want to prove okay, for all x in the domain of t that we've got tan squared of x, which is equal to 1 over cos squared of x minus 1. So how to deal with this kind of things? What do we know about tan squared of x? This is equal to sinus squared of x over cosinus squared of x. Okay, this is really easy. And why do I think of that? Because I see a cosinus at the bottom and I know how to have a cosinus at the bottom. Now I want to get rid of this sinus thing. What do I know about sinus and how do I relate it to cosinus? I know that sinus squared of some angle is equal to 1 minus the cosinus squared of the same angle. Okay, and why does this equation exist? Because, of course, cosinus is not equal to 0 because of this condition. So this thing is equal. Let's write it down again. 1 minus cosinus squared of x over cos squared of x. And this is equal, if I simplify, to 1 over cos squared of x minus 1. And we have solved our exercise by finding the right equality. And so we still give the domain of equality for all x in dt, the domain of the tangent. We have solved all the exercise. Hope you enjoyed the video. See you soon. Bye.